Hello and welcome back to this series about learning Java, and today we are talking about interfaces and enumerators. To start with, I've written a class called car. It is a very basic implementation of a car. We haven't seen this class yet, but this video is not about classes, so I'm not going to waste time trying to write all of this code. I'm just going to explain what it does. We have two variables up here, properties of this class, key turned and speed. It's a boolean, whether or not the key is turned, an int, how fast the car is going, and then a boolean called running, which defaults to false, and an integer called position, which is equal to 0. Then I have a constructor. It takes one input, the speed that the car is going to start at. Car usually starts at rest, but maybe when we construct our car, it's already running. The key is not turned when we start, and the speed is whatever we set the starting speed to be. We can start the car. It'll turn the key, so make this make key turn true. It'll make running true, and it'll print out the car is started. We have this method move, which takes this new speed. I don't know why I wrote it like this. Maybe it could work without this if the car is going to keep moving at the speed it's already at. But this is how I wrote it. If it's not running right now, we need to start the car, and then we're going to move the position by however fast we're going right now, and then set the speed to the new speed. And then one more method which displays the current speed of the car, just returns the speed. So in our main method, which is what runs, I'm going to create a new car. My car. It's a new car object, and let's say it starts at 30. This isn't the speed the car is running. It's the speed the car is going to start running at when it starts moving. So I want to start the car first. Start. This will print. Car has started. Now the car is running. I want to move the car by the current speed of the car. Remember, I can use this dot notation to get properties. So it's moving by the current speed property, this integer of the myCar object. This doesn't print anything. It just updates some of these variables. And if I then ask it to display the speed, display 30. The speed hasn't changed because the speed we passed in is the speed it already is. So the speed didn't change when we called move, and now it's just going to display the speed and print that out. Okay, here are some things we can do with our car class. Now I'm going to do something a little bit different, and rather than just have a car, maybe I want other kinds of vehicles. To start with, I'm going to create an interface. Like classes and all other objects, we start with the name of the thing. So it's called an interface, static. I'm going to call this vehicle. So this will work for all vehicles. Now, interfaces are very basic. The only things you can put in them are methods, and you can't put any code inside the method. So I can write public void start. In some way, each vehicle needs to be able to start. I don't specify in the interface how the vehicle starts or what it needs to do when that happens. I just say that there is a method that can do this. In the same way, all vehicles should be able to move at some speed. So I can put in, this one is empty, takes no parameters and returns nothing. It just runs code. This one takes in one parameter integer, but returns nothing. Or I can return an integer. This is going to be a display speed method. I can't put anything else in this interface. I could make more methods, but I can't add code inside any of these methods or add properties like I can in a class. This is all I get to do. Now I'm going to make my car implements vehicle. Instead of extends, like we do for parent and child classes, I have implements, which says vehicle is an interface, and car is going to use some of the methods, or all of the methods, that the interface provides. And now when I do this, okay, so this just works. Rather than having to use override, like we had to do for the for our classes, there's no coding here. So there's nothing to override. Here I'm just saying, I want to start the car. We haven't provided anything that this would do anyway, so I just say, this is what the method does. It would throw an error, I think, if I didn't use one of these methods. I specifically created these methods because they're the methods I already have in the car. But if I wanted to make more methods in my vehicle, I would also have to make it do something in the car because the class car is implementing the interface vehicle. One more note about interfaces. They're not classes. If I try to create an instance of vehicle, it throws the same error we saw last time and instantiate this. You can't create an instance of an interface. Its only purpose, like an abstract class, is to be implemented by classes to give a framework for what method you're using. Personally, I find interfaces very unhelpful because you haven't really saved any time. I have to write each of these again when I define what the method does. So all this says is I need these methods. It's more like a reminder to yourself or to somebody else who's working on your code than an actually useful part of the code. It doesn't do anything. Now, I'll add another thing. So I said at the start of the video, this is about two things, interfaces and enumerators. So now I'm going to create the enumerator. I'm going to put it at the bottom of my class. This is standard practice. I don't really know why. I'm going to make a public. Enum is short for enumerator. I'm going to call this car settings. And all that I put in it are, I'm going to put these in all caps. Running, electricity only, off. And enum, or enumerator, is like a class. It has a lot of the functionalities of a class, but it only has certain values that it can take. So I'm going to change key turned. Right now it's a Boolean. It can be either true or false. If I wanted it to have more values than that, I'd have to make it a different type, like a string. Instead, I'm going to make it a car settings type. And now it can take any of the values that I specified in my enumerator. There are other things you can do with enumerators, but the main purpose is that it has a list of types, and that's the only values that a variable of that type can take. So I can't make this true or false anymore. That's why we got these errors when I try to make it true and false. I have to make it running, electricity only, or off. So here I'm going to make this off. Car starts off. This won't work. I can't just say off. There's no idea what off means. Instead, I have to make it car settings dot off. This is kind of like a property of the class. And when you do more things with an enumerator, it really looks like that. It's a variable that you've defined inside the class, but it specifies for objects of that type that it can only be one of these variables. Those are the only values that a variable can have. And this one I'm going to say our settings running, because when we start the car is now running. And I'm going to add another method down here called half start. I haven't used my electricity only yet. I want to be able to make whether or not wait, I did this wrong. The key can only be turned or not turned. I don't know where it is. So I'm going to put this back in a Boolean and change back the things that I did here. They should still say false. This one should still say true. instead I want whether it's running to be, so it defaults to being off. Just a note, this variable key turned, I defined in my constructor, and this variable I initialized here. What's the difference? Really not much. There are some cases where you construct an object at a particular point in your code and you don't want it to have a value before that. Most of the time, it doesn't really matter, because if there isn't an object, you can't initialize it anyway. Sometimes there's code you want to run when you initialize an object, so that's what you'd really want to put in the constructor. Or sometimes you're passing in variables to the constructor, so that's why we have this line in here, because I don't know what this value is beforehand. This one I could make it up here. It doesn't really matter. Now I have the errors about this. So if this starts running, this should say car settings stop running. And this one, instead of not, I can't just put a not in front of that. It's not a Boolean. So if I'm going to say if it is equal to the value car settings dot off, because its value is either car settings dot off or car settings dot running or car settings dot electricity only. Only if it's currently off do I want to start it. Realize you'll probably be doing this if it's electricity only. It has to be running to move. But we're going to make another method, kind of like start, called half start, now that I've fixed the thing that I needed to do. I still want key turned to be false, because I haven't really turned the key all the way. I've just set it so that the electricity is on. So now I want to say that this dot running is at car settings dot electricity only. Oops. Because their car is now in the setting where it can run the electricity like Windows and a radio, but it can't actually move. So now let's make the car do some things. I'm going to make the car half start. It's really half unstart because it's already started. And now if I print my car dot key turned, you can see that this is false because the half start method made it false. There's a lot more you can do with enumerators that makes it look more like a class, as I said. You can find a lot of information online. I don't even know all of it myself, but I do know there's much deeper you can go into this particular thing. That's all for this video. I'll see you next time.